Hello, fellow Mythrunians, and welcome to another weekly live stream. It's been a kind of a crazy week for me, so I've been really looking forward to this. So hopefully we can get a lot done tonight. I know last week's stream was pretty good, so hopefully we can keep that momentum going. Before we get started, that's the patrons list that's scrolling down there. And yes, since I just did my taxes, I'm really glad you guys are still contributing. Really appreciate it, so thank you. Up in the upper left corner is the up in the upper left corner is the link where you can download the most recent version of the game. Just put that link in and hit the password. Or if you hit my Blue Sky account, I've also got a pinned tweet there that you can just click the link. Blue Sky link is in the description of this video. And of course, it's live stream, so now my nose is going to start itching. Okay, so let's minimize this. I'll show you. I did work on Mythruna proper last weekend. It seems like the chat window is not working. Let me see if I restart that, if it'll work. Yeah, that's fine. Docs, chat. Is it gonna work? Is it gonna work? Is it gonna work? Yay! Hey Ron, how's it going? Alright, so let's move that down. So real quickly, one of the things that, so sometimes when I watch my older child test the Linux version for me, I notice things that I sometimes don't notice myself, so watching somebody else use it is useful. So any of you who making videos, I watch them when you make the, I try to watch them because it's sometimes interesting to see how you play the game. Anyway, I really like these screens. They they always make me want to play the game. Alright, so used to be when you were creating a character, when you were adjusting things like hair color, like even just dragging this slider was really jerky, but now you can see I can drag it all over the place. And she just updates with a bit of a lag now. But it used to be that lag was what you felt when you were dragging this around. It was really frustrating. And so I want to be able to let you guys select clothing for her so she doesn't have to enter the world naked every time, you know, or in her underwear. But yeah, skin color was really bad before, and now it just updates late. So I think that's much better. It's a much more fluid UI experience. We can make her like an Orion. It's probably more like this, yeah. Anyway, so that's what I did. And I did play a little bit with trying to rearrange that screen so that it has like space for a portrait. And so I'm still messing with that because I would really like to put like a character portrait, especially when we get to the point where you can select your own eye color and, you know, different facial features and things. I would really like a portrait. And I'd like the ability to kind of like turn it into like a hand-drawn thing that we include in the game. You know, whenever your character has like a journal or whatever, you could have the little portrait up in the upper left corner or something, or in dialogues or something like that. Anyway, the other thing I did was, yes, cancel character creation. It's a silly thing, but it made me deal with some long-standing screenshot stuff that I wanted to deal with. But Ron mentioned that he wanted some indicator that when you took a screenshot was actually happening, because it wouldn't make a sound, wouldn't do anything. And so I added this little animation, which I'll show you in a second. I just wanted to get into the game to show. Also, I was working on what it looks like to have a partially constructed house. So yeah, now if you hit the screenshot, it's, well, why isn't screenshot actually taking a screenshot? Oh, I think F12 is being intercepted by... Why can I not take a screenshot? Is F12 not working? F12's working. Okay, that's new. Oh man. I literally haven't done anything to the game since adding that. So, oh my gosh. Yeah, OBS is having fun because I just hit a bunch of keys it doesn't like. That's what it is. So, OBS has this key remapped, I guess? No. What were the numbers on the top right? I don't know. I don't know what numbers you're talking about. So yeah, so I'm wondering if OBS is preventing me from doing screenshots. It doesn't seem to have hotkeys defined for either F12 or... That is strange. Oh yeah, coordinates. Yeah, so that's my overlay. Let's try again. Just, whoops. Yeah, I don't want to do that. Let's try one more time. Maybe something about... Oh, I know actually what it was. I know what caused it. It actually was related to the character editor that we went into. In order to get... one of the very last things I did this week was in order to get... I don't know if you guys have ever taken a screenshot of the character editor before, or the appearance editor, but the character actually wouldn't show up in there. And so I fixed that. And, yeah, I fixed that, and when I did, I think I broke regular screenshots. So I need to fix that. But as long as we don't go into the character editor, we should be fine. 1 second. Well, I mean, I can show you the effect anyway. But, okay, we'll just go in. It takes no time now. I already took up all the time. Yeah, so, and I wanted to go in to show you what those upper coordinates are. So, in your settings, you can go and you can change... In the user interface now, you can set what your overlays are. And so I have my overlays set to be the world seed and the coordinate. I think that's the default, actually. And so when you don't have the debug HUD up, it will show this overlay, and I have mine set up in the top right with that particular font, which I find I like that particular hand for. I like for coordinates. But yeah, so if I had like hit F9 to turn back on the debug HUD, it would turn that off. So anyway, so now if you hit screenshot, drink. Oh, it's still not working. Okay, I've fully busted screenshots. Anyway, it makes a little, it like captures the screen and like looks like it's in paper, and it pulls the paper off. That's what it does. Yeah, so when I added the character support, I must have fully broken screenshots. So I apologize for that. If we run out of things to do at the end of the stream, I'll fix that real quick because it's a quick thing to remove to make it start working again. But let's get back to this, our playground, and doing pathfinding. As you may recall, on last week's episode, we got to the point where we were having like a bunch of Mythruna girls running around. And so yeah, this has been a crazy week at work. I had to work a couple 12-hour days, that kind of thing. Not a whole lot of... Oops, that's messed up. Yeah, if you really want to see, there's a clip on Discord. And in the upper left, if you go to that link, there's also a link to an invite to the Mythruna Discord, or the SimSilica Discord. So I've been... yeah, I need to fix that. I broke that. I was messing with making all of these things, all the little debug, come on, there we go, all the little debug things toggleable. So now we have layer toggles. We can toggle on and off the probes, or the goal, or the pathfind, or the path status. And so then as things get added, it will add new layers. So if we get to the goal, our paths will show up. And so that means that I can show the path or not as we see fit. There's apparently a bug because it leaves behind garbage. But that's neither here nor there. It's working well enough. Hold on. Oh, man. I think the pollen is starting to come out. And so the next thing I was adding was global actions. Like, so I put these in a thing, and apparently I broke that, but the ability to, because I thought it'd be cool if we had a bunch of these guys to just make them all go to the same place. And so I was adding that feature, and I was literally just trying to finish it when it was time to start the thing. So let's see if it's working. So I should be able to say set global action rally. We'll just call it rally, and that's it. Log info rally. Okay, so that ran, and now we've got a rally action here, and we can click it. The layout is messed up, but I can fix that real quick. We will have to restart the tool though, because that's actually UI stuff. Where did I break that? Why is that broken? Oh, I know why. Yeah. There we go. Ah, that makes sense. Okay, so now, so now we could make later on in the stream, if we get to wanting to play around with multiple mobs, we could make a thing with the thing. We could just have a bunch of mobs. We could click a button and put a point, and they all run to that point or whatever, automatically pathfind to it. That'll be like our dessert if we get dinner finished, so to speak. Yes, so see, it knows that rally. Yeah, I'm not sure what it would take to actually implement that off the top of my head, but I wanted the ability to have like global actions that weren't specific to a mob, because I already have the configurable per mob actions. Okay, so today what we want to do is make it so she can walk upstairs. I mean, if we get that done, I'll be super happy, because walking up and down stairs and walking up and down ramps, which by the way, we don't have any ramps. Maybe let's add some ramps real quick. If you guys are okay with that, we can see how that works. Tools, blockhead 2, Gradle run. So we'll quickly add some ramps to our little playground. And then, because we haven't actually tested ramps with even the pathfinding, so this may be interesting as well. So this is the block editor tool. It actually comes shipped with Mythruna, I think. You just can't easily get at it. Playground 2. Alright, so one of these has ramps. We want to probably put, I think maybe we can put some ramps inside here. That would work. I kind of liked having the big open area, but, or maybe here, yeah, because, I'm trying to keep it out of the way of her. I think maybe here we'll put a ramp up here to get up here. Okay, which block type has the... I know all does, but maybe gray. Does gray have wedges? It does. Alright, which wedge do we want? Not that one. This one. So if I like put this here and here, and then we can put this down there. Right, now we've got a ramp. And a little bit of a pinch right there that'll be interesting to see how she deals with. Alright, so save that. Copy sample block files playground 2 dot dot rigor sample 2 block files. Yeah, I think so. Oop. Unless I copied it. Apparently you can spell yes however you want. Okay. Blah 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 blah. Yeah, we're doing Q3 planning at work, and historically speaking, we have not done planning very well, I guess. More of a seat of your pants kind of development, and so they're real quickly trying to like cram a couple weeks of planning into 3 days. And that's lots of fun. Okay, so look, we've got our little ramp over here. Now I just want to see if she'll create navigation up there. So let's do path 2 up here and see how she gets there. Let's move around to this side so we'll be able to see what she's doing. Okay. Okay, is she going to go up the ramp? Nope. Okay, so that's a problem we will deal with another time. But she will find her way up there because there is a path. It just takes a really long time. So let's clean the path. Okay. Let's get her to arrive over here. Okay, she's back in our little safe area. The things that are going to be configurable per mob type, which is something we'll get to eventually. Okay, so wow, this is really slow. Mob type specific stuff. So one of the things, the biggest thing maybe, is well, not the biggest thing, but the collision shape that we use. Hi, Max. The collision shape that's associated with that body, but also what path directions are allowed. For example, a fish or a bird can go in all the different directions, whereas a walking, gravity ground-based character would be limited to what they can step up onto, and so on and so forth. And other characters might be able to climb, and so on. So mob type specific stuff, those are going to be the big things. There's the standard stuff, which is animation parameters, like how fast they walk, which animation they use for that, which animation they use for moving up in the air if they can fly, or so on and so forth. And the other one is so if you got what path directions are allowed, which way are they allowed to move? Like, can they free fly and through the air? Do they have some kind of glide, or can they step up over things? So when we do the pathfinding, that's fine, but then the physics part of actually moving through the environment and following the path, which way are they allowed to move? These two things are closely associated, but they are not the same thing. But anyway, that's the next problem. We've got to sort of figure out how to make the ones we have already work, because we picked the one with the least flexibility, a human. They've got both the problem that they can't fit through small doors, and that the only way they can get up and down things is through steps and ramps. And it's unfortunate the ramps didn't just automatically work, but that's the way it goes sometimes. And I suspect, there's that little bit of code that, looks around to see what collisions are happening for that contact shape. And I suspect that it's just not taking the ramp direction into account. It sees it as a wall instead of a vertical surface. So the other thing is, right now her probe is just a sphere, and so I think we need to switch the probe to be the same collision shape we use for doing the pathfinding, which is a cube, not like bigger than what's here. I don't think we dropped down. Yeah. So I had that test that showed like what the collision shape looks like. It's a 25 centimeter by 25 centimeter, or 50 centimeter by 50 centimeter. That's probably, yeah, that's what it is. Half a meter by half a meter box that's taller than she is, so we can detect when she's about to run into something, and it goes down below her feet, so we can detect when there's something she can step down onto. And that's what we use for pathfinding. So we know the difference between a ledge that she would fall off of and a ledge that she can just step down to. And if we use the same collision shape for both, man, I wish I'd done this on purpose, but I didn't. If we use the same collision shape for both, then these two start to resemble one another. Because, how she can move through the environment, which with her probe, starts to look a lot like how she determines which paths she can take. And the closer we can make those, the better in the long run. But anyway, so let's talk about, let's just warp her over here. Alright, so let's make a path to, it has to be far enough away that we get an iteration at least. Step. So she detects that she can go up here. Come on, there you go. So she detects that she can go up there, but she doesn't know how to step up yet. So that is what we will work on right now. And her probe is going to hit that, but I think not in a way. Can I turn on contacts? Oh, it's not going to debug. So we might want to add the debug contacts for her probe so we can see sort of what her probe is intersecting with, because that is going to be useful. Like if I try to arrive here, she can't get there. She's going to continue to just bump into that wall. And so regardless of the pathfinding, we don't really even need that. We can test with the arrive behavior, really. And actually, let's make her arrive here so she'll actually stop. Clean the path. So I'm just trying to think of a repeatable. So if we warp her to here and she eventually settles down, she is not settling down. There we go. And then we should be able to just path to, come on, stop flickering. Should be able to just path to here. And that should be enough to see it work. So, where this happens is actually in the character driver, which we've sort of hooked into scripts at the moment. So it actually doesn't have anything to do directly with pathfinding. It is, as she hits collisions, is she trying to step up? And there's a couple things at play. Okay, come on. Come on. Come on, you can do it. Come on, Miro. Be a pal. So I'm trying to think if we've got, yeah, so we've, oops. Yeah, now I've already forgotten what I was going to say. Thanks, Miro. But yeah, she's got to know to step up. So as her probe hits this, which, you know, the probe is eventually going to be this big, tall thing, but we can still work with, I think we can still work with the circle for now. So she's got this probe that'll extend in front of her in the direction she's walking. And so if we detect, I think the contact will look like this. And so if we detect that, we need to decide that that's not just a glancing blow. It's not something we need to steer away from. So for example, from a top view, like say this is her head and she's facing this way, and we hit, actually, let's say she's walking this way, right? And her probe is here, and it just happens to glance this step, but she's actually going this way. In that case, we would want to treat it like a block, because ultimately she's trying to get over here. She's not trying to step up there. Otherwise, it would look really weird to have her go through the trouble of stepping up on the block just to step back down again. So it needs to be, we know we're trying to head in this direction, and this thing is in our way. You know, it is very in our way, not just a little bit in our way. And we are trying to go up. You know, that would be nice too, if we knew we were trying to go up. And that's where the pathfinding can come in, because like just normal pushing forward, we don't necessarily know that that's what we're trying to do. So I think all of these things, the pathfinding's desire, the steering system's desire to go up, we need to keep track of that. The yeah, and in fact, if we keep track of the steering system's desire to go up and just don't factor that into our velocity, we can factor it into when we detect contacts that we could step up onto. I like that idea, because it also feeds into when we can fly. So in this case, again, like the other thing is, the more similar we can make each of the different character types with respect to how they move through the world. Like if a bird and a person are very similar except for just a couple things, that's better, rather than having to customize all movement. And so if steering can be 3D, but just usually isn't, that would be okay with me. Or if it's always 3D and it's just that walking characters ignore the third dimension or only factor that into, you know, what they're allowed to do. Because the other thing is, if she hit the wall and there's a ladder here, is it a wall we turn away from, or, oh, hey, we've intersected a ladder, should we climb up? Because we're trying to go in that exact direction. So I think that's useful. So let me fix steering. We've got an up, and we kept up down. We just didn't do anything with it. So we could just set, we want y equal up down. So that's our arrive behavior. And similarly, it makes me very happy that arrive and follow path look so similar. Okay, so now we have up down, and I'm pretty sure we're ignoring it. Down here where we update, where do we get the steering input? So this is where we calculate actual velocity. That's not what I'm talking about. Here we go. So we calculate the steering. We've got the move vector. Move vector, which is kind of like the joystick input, if you want to think of it that way. And then we use that, right, to figure out which way to go. So we use X, Y to turn. We calculate a force. We set the Y of the force to 0. That's perfect. Okay, so this is perfect. She should still behave like she did. And if we tried to make her arrive up here, she's going to fail. She's going to, yeah, okay, perfect. She's not trying to get up there. Cool, cool, cool. And yeah, she's going to be unhappy with me until I put her back over here. Okay, so she's happy, Mythruna girl again. And okay, so let's add, when we get contacts, new body contact, I want to look up the state. Do I get the driver? I do. Okay, so this is going to make all contact resolution a little slower. And so body state, let's to that add, we've already got path data. That's something else. Contact entities. I just want to be able to add, reuse the same ones over and over again instead of constantly recreating them. Oh, these are the body contacts. It's the probe contact we want to deal with. Actually, it's both. As she slows down, the probe will slow down. So I think we might be able to deal with this one first. So, okay, so this is checking upness. Currently 45 degrees. Else, let's just log that she could walk up it. Log info might be able to walk on. And see what happens when she tries to go up here. Oh wait, we had an exception. Oops. I hit escape. Line 850. No, that was a different one. Is that driver.groovy 850? Bad things are happening. Body state, okay. Okay. 406. Oh, I already, yeah, I grabbed it down there. So let's just grab it once. That's not why the app closed. I hit escape because I was trying to close the thing. And that's not how you close that anyway. Poop. Got to reset up. Oh, poo. Alright. Let's put her back here. Let's move our thing. That's one of the global actions I could add. Is okay. Yeah. So she's basically it's telling us about the floor she's standing on. That's not really what we want to know, but alright. Yes, so we need to know that it's facing us. She's not close enough to hit that yet. Let me change the probe a little bit. Guys, help me remember that I'm doing this. I just want the probe to be a little. No, this is actually not gonna help me. Well, it will. No, what I want is a kind of a temporary probe that won't affect steering, that I can just see what it's going to do. So what I'm thinking, it's good to see what's happening, and so what I want to do is I want to put a probe here that will get events about, but that's not actually affecting her steering, so that we can just see what kind of contacts we get. So let's give her a second probe. Alt probe equals null. Alt probe entity equals null. And then I want to double check our probes to see if they can take the body state, because that would be super useful. Yeah, for now. That way we don't have to look it up all the time. That's just a convenient place for us to store our garbage because we don't have our own driver that we can put state in. We're plugging in Groovy scripts. And so we have to find all the places where we're creating new probes. And so here we say state. Yeah, okay. Boink. And so where we do this, we want to say alt probe equals new probe. And this one we'll put out, let's put it out 0.5. We'll make it the same size. And we will create an alt probe entity. So we have something to look at. So have you all had a better week than I did? Actually, on top of all that, working 12-hour days, I had a couple nights of insomnia where I woke up at 3 a.m. and took me 2 hours to get back to sleep. So, because I didn't have enough going on already, right? Let's make this a different color. A pink. Pink will be good. And so if we do this, alt probe. Let's try this again. Oh yeah, no, okay. Cool. This is why being able to visualize things is a good idea. So then you can put it in the place you want it. Oops. What did I mess up? Did I? Oh, I accidentally put an A there. Oh wow. Ooh. Yeah, there's another person on our team that's been sick. Fortunately, they weren't involved in planning, but they've got a small child as well, baby. So yeah, everyone, I don't know. I keep hoping it'll get better. All right, so let's all right, so state.probe. I want to see where we give it its contacts. Okay, so where we want to do this is we just want to grab it, and then if true, alright, so this is for alt probe. And that's as easy as that. And then, okay, actually I want to make this one super transparent. So let's give it a different color. New color RGBA. 1.0, 0.5, 0.5, 0.5. Can I do that? There we go. Hey, I got pink. I got semi-transparent pink right off the bat. That's not bad. Alright, then the next thing. We've got our state. We're good. Let's do contact. And so we will say... the thing is... I guess it's going to be fine. So... we don't have access to entity data here. So... I got an idea. Let's add a list of probe contacts. Probe contacts. And then in the probe, whenever we get a new contact, just add it. And whenever we reset, actually, we'll reset it down here. Because we've got two probes and they'll both be filling it in. So that could be useful. So both of these we'll call probe reset, and so here we will clean out the old entities, state dot probe entity contact entities dot each I kind of wanted to reuse them though, so we won't do that. We will call state dot probe contacts dot clear, so we'll clear out any old ones we had. Let these guys fill it back up again. And then do a bit of a weird loop. State dot contacts probe contacts. Size I plus plus. Okay, so if we have a probe, or if we have a contact, yes, but I want to keep the loop variable. Okay, so probe contacts I, that's the contact. Somewhere I have visualization for contacts already that I can cut and paste. Don't I? Yeah, something like this. Just gonna put that there for a second. So then we want to see if we've already got an entity. Oops. State dot contact entities. I less than size, then I, else null. If contact entity equals null, we gotta create one. Contact entity equals ed, create entity, add it. So this is just so I can not create a whole ton of entities all the time. But in point of fact, there's no reason to save them. Oh yeah, the debug state will be happier if we save them. The thing that's generating these geometries will be happy if we're just updating something already than thrashing the scene graph. So let's call this probe contacts. And we want the... Oh, you know what? We can grab more than that because the CP and the contact point are over here as well. Contact, okay, CN, blah, 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 blah. All that's good. We've already got the... And yes, we will add it to the... Not path entities. The thing that gets cleaned up automatically when we... It's called cleanup entities. Cleanup entities dot add. Contact entity. And so this is the good. And then here, contact entity, and we set the things. And then, that's good for that loop. And that will make them grow and never shrink. And so now we can say, we've already got an I. If I is less than state.probe, or state.contact entities dot size, then we will I know it's like weird to steal this and then delete all the things, but I think it's less typing overall. So then we can say we'll just remove the debug shape. I think that works. Whoop. Something's unhappy. No such property probe contacts for class probe. Oh. That's... Okay. Oh, I didn't... It's state.probe contacts. Okay, now we've got a different problem. Okay. No. What was the line number? 616. Okay, that's right. Somebody grabbed it, didn't they? Oh well. This works. Okay, I'm gonna be happy. Okay. No such property. Arrow color. Oh, sure not. What do we want to make these? Let's make them cyan. One of my favorite computer colors. Okay, so see, now we can see that probe right there has a step. We could, if it was this probe, we would know there's a contact there she could step up onto. You know, I actually want to make my own blocks, like real life blocks, out of wood that are the same size as these, because I think mostly like sometimes I film my own animation reference, and I want to know what it looks like for a person to try to step up on a 50 centimeter box, because this is really quite tall. So I want to make my own, and I want to make my own meter box so that I can see what it would look like for me to casually hop up onto a 1 meter tall box. You know, like realistically, that is not something that you just walk right up. And you know, even though in Mythruna we kind of let you just kind of step up onto the 1 meter blocks, but I just think it would be funny to set those up in my backyard, a couple of them, and film myself walking up onto and so on and so forth. Because if you look at her, like this is up to her knees. Like this is quite a big step. So you're not just going to casually kind of walk up that. Realistically, we'd have quarter blocks for steps. That'd be pretty good. All right. So we know that if we have a contact from our probe that is pointing straight up, then we are heading in that direction. Animating that won't be simple. Yeah. Yeah. That's why the Minecraft characters all bounce around all the time, right? They're all constantly jumping so that they can get up the 1 meter blocks. Even the cows, you know, jumping up. I haven't quite resolved how I'm going to do that yet. Or maybe I just make sure the world generates with more half blocks so that there's always a path, which would frankly be a lot nicer anyway. It would definitely make the world more distinct if there were more half blocks instead of, you know, sheer 1 meter little mini cliffs, you know. So let me think about how to get this contact into... because these are down in the probes. So the probe needs to make the decision whether to turn away or not. The probe does not know what we desire. Actually, it does. Because we define move up here. Yeah, and we calculate main steering. Okay, so yeah, we create a whole new probe movement input. But we could have passed the original one into probe calculate steering so it knew, and the probe could decide. I gotta think about this a second. This is the paradox of software development. You know exactly what you want to do, you just need to think of the best place to put it where it has access to the things it needs. And turns out the part of my brain that I use to do that is also the part of my brain that I use to host a live stream. So it takes me a minute. So I'm going to talk it out loud instead of writing it down. So a probe gets that. The probe wants to know whether to steer away or not. So it needs to know, does it consider that a contact that's in the way? So at minimum, whether we give it the original probe movement input, or we pass in our move, or we give it both. It's going to need to know what we desire to do. I think that could clear up a lot of things. So we will pass in move as the first parameter. This is what we want to do, and unfortunately it yeah, so mech 3D, call this default move, and we'll and so then avoidance, contact avoidance. Okay, this is interesting. So the contact avoidance is what the player uses for their own body contacts, right? So this is starting to unravel my off-the-cuff design here. So we've got near avoidance. Do we ever use near avoidance? Yes. Okay. Oh, we use it as sort of the initial probe. Sure, sure, sure. So it will also need the original move. And I think we pass the contacts through on directly. So it will have everything it needs. I'm wondering if it'd help you guys if I drew a diagram of what I'm doing here. So let me maybe do that. Well, not so much a diagram as, okay, well, let me make the compiler happy. This is probably default move. Oh, great. It's also nice to not be able to spell today or have typos. That's great. Okay, so everything compiles. So I'm trying to decide. I think I'll just do this in the text file. So when the rigid body, which is the just general physics thing, it has a driver that so a normal rigid body, how things work. Rigid body, normal physicsy thing that flops around in the world. If one of those, in this particular physics engine, if one of those has a control driver, makes the rigid body able to supply its own forces and behaviors. So it can add things on top of what the normal physics engine is doing. So a mob has a control driver that is what's responsible for keeping it standing upright, and it can receive all the contacts, so control driver receives, is it I before E? Yeah. E before I. Or receives body contacts, update called every frame, and so on. And so it receives all the body contacts that, the physics engine has, and then it can do something with those, when it's called. In this case, we take, the mob's desired input, we turn that into physics forces, and we have them try to walk around in directions. But we are also receiving all these body contacts. And so what I have is I have a collision avoidance steering. So there's our main steering, like to follow the path, or arrive, or wander, or whatever. And there's the collision avoidance steering, collision avoidance steering. Gets contacts decides how to turn away, right? And then there's a probe, and a probe is a non-body or body relative position to predict contacts the body might receive, and passes those. Let's make this body relative position predicts contacts the body might see soon, passes them to its own collision avoidance steering to predict better steering, right? And so this is kind of cool because whatever I do, I want when the player itself is hitting the step, I want them to step up. When the probe detects that there's a step there, I want it to let the steering continue to let the player hit the steps. And since they both all end up in this collision avoidance steering, that is where I need to implement the logic. And so in both cases, it's like, let the player continue to walk in that direction, right? So, and if I just do that, implement it here, it knows the contacts. If it sees a contact in front of us that's, low enough and pointing up that we could step up onto it, it doesn't consider that a blocking path. So that's the organization of the code we're in. And so collision avoidance. So what I wanted to do was pass the movement out of the main steering, which says, hey, I want to go in this direction. I wanted to pass that movement on to these guys so that they could use that in theirs, because if I'm just glancing this because I'm heading over here, I don't want to step up onto it. But if I'm trying to head actually in that direction because I'm trying to steer in that direction, then I do want to step up. So that's important input. And so collision avoidance will take that, our original default move from the main steering, and that is what we need to do. So if forward is greater than 0, so we collected all the contacts, and we used to have we want to keep track of, we don't actually know which way we're moving in the place where we're collecting the contacts. And normally we just, we add them all. And we figure out whether they're in front of us. That's good. And yeah, so here we're kind of calculating the closest contact point. That's fine. So closest contact, in this case where there is only the one, it'll be the closest contact, and we do keep track of the whole contact. So in here, if 1.0, then it should be is. If size 1.0, then object is relatively far to the left. But okay, so we kept track of where it was in front of us. We kept track. Okay. Depends on the relative position and not our mobs facing dir. Right. And in this case, it's not facing us because it's pointing straight. No, it's the direction, not the... Yeah, contact normal's pointing up. It's orthogonal to our relative position. No, I guess not necessarily. wonder if we need to keep track of all of the step-ups that we could make. If the contact normal is facing us, we want to know if the contact normal is facing up. So let me steal my upness code. Okay. Oops. There we go. Yes, this is another parameter, right? What angle of surface can they stand on? So log info could stand. And wait, upness slash or could not stand. Upness would be 1. Let's try this. Whoopsie. Oh, I don't have access to log. Yeah. So go to system out println or println. Inside classes, I don't have access to the global properties. Yeah, so they could stand on it because so upness, that's the dot product again. You know, when we have a vector in a particular direction, you can think of upness as telling us how closely related the y, unit y is the vector pointing straight up in the air. And how closely related are that and the contact normal. If it's 1, that means that our contact normal is pointing straight up. If it's 0, it means it's laying down, pointing straight down. So if it's facing, no, it's a different kind of facing. Yes, facing, we want to know facing our direction. If it's in, and it's in front of us, in our direction, which is relative to dir. Dir is what? We calculate dir when we reset. Cool. So dir is the direction we're facing. And relative is, so yeah, if we just calculate this earlier, if facing is positive, that means the contact normal points roughly in the same direction that we're facing. So it's the backside of something from our perspective. Yes. Let me just make sure that behind us, make sure that this one doesn't count as behind, because there's a, yeah, that's what I thought. I think it does. Because regardless of what direction, if we are like directly horizontal from it, yeah, that's not what we want to know. We want to know if it's in our path. So if it's in our path, so if it's kind of standing straight up, wow, it's taken me halfway through the live stream and I'm still doing vector math. And in our direction, so if forward is basically positive would mean that the relative direction of this contact is very close to the direction we're facing. So like a 1 would be very close. 0.7 something is about 45 degrees off. So we'll probably use the same front threshold so that we're paying attention to things that are about within 45 degrees of our front facing. So if front threshold is greater than and relative dot y, well, let's see, what is relative dot y? Because we're kind of relative dot y. It's like there's a problem that the rigid body's center of gravity is actually at the feet, which is going to be something I have to fix later, and then I'm going to break a whole bunch of code that considers the rigid body at the feet. How is that at 0.3? Yes, we're not. It's not exactly at the feet. Let me body position dot y. I'm just curious. Yeah. So see, her body position is somewhere. It shows this. Yeah, her body position is this yellow marker right here. And I don't know why that is. Oh, that's because that's the center of her root. Uh-huh. Okay. And so we need to know. Ugh. So this is another thing we're going to need to keep track of. And right now I'm just going to hard code this to 0.1812. 0.1812. And so if I double y relative equals relative dot y plus cog offset. Y relative row. That's not really in front of her. Not according to this. Print line forward. Dir. Relative. Oh, because it's not her. Yeah, no, that should be fine. So it's forward. It's because it's not normalized. Yes, of course. I'm being dumb. I'm being dumb. I can't do front threshold that way. Because not that. What do I want? I want the Miro. Because while the dot product, so she's facing this way, right, and the contact is right in front of us. When the contact is less than this, distance of 1, then it will show that forward will be here. It'd be the same as if it was over here or over here, which I'm using it to try to determine the angle, but I can't because anywhere in this range, it's going to look like it's in front, right? And anything out here is going to look like it's outside, even though that's really what I want. I can't use just forward for that. I'm going to then... I need to use both or normalize, and I'd rather not normalize. So for now, let's just consider if front threshold is right in front of us, like not behind us, we're good. But that means that glancing blows off. Actually, this is okay because it's only in front of us anyway, so that's all good. Okay, so we know we have something we could step up onto. We know it's within our threshold. So, do I want to do any more than that? I want to keep track of it. Let's say double min closest step dist squared. Closest step. Okay, so this is a step. It might be a contact, but what we'll do what we shall do forward equals forward. What's that about? Okay, I don't care about that. Closest step equals contact. Min closest step dist, closest step dist equals dist squared. I don't need that. I don't need that. So basically we're keeping track of the closest step we find. I'll do this so it stops filling my log. And so when we are calculating steering, we will have a contact that's in front of us. Like if I print this, something in front, right? It's going to say there's something in front of us. Oh, there's not. That's because it's pointing up. That's because our probe is sitting right on top of it. But we should still consider that a potential contact we want to avoid. So something in this calculation is not right. I think it's the same problem. Because the contact normal is facing up, or the contact normal in this case, contact normal is facing up, but the relative position is also up. Thinks we're facing away. Why does it think we're facing away? Okay, so it thinks we're... No. that's not right. If facing is positive, then that means the contact normal roughly points in the same direction that we're facing. No, that's not what it means. So it's the backside of something from our perspective, but that doesn't mean we can walk through it. I think this is bogus, really. I'm going to just take this out. I don't think facing away means we can't walk through it. It just means glanced. We may have partially passed into it. Okay, so took that out. It still doesn't come up as a step. Because forward equals forward. So it should be... I know this is exciting as watching paint dry, but this is the math here. So it's behind us. So what is forward? Forward is 0.5. Yeah, I calculated that already. It's not behind us. So forward equals forward. Distance less than min distance squared. Oh, the other thing I didn't... Oh, you know the other thing I didn't do is min closest step dist. So like the first one we saw was going to... potentially prevent all others from being seen. Oh. It's even worse. Is it behind? Oh, I took the print line out. That's why. Freaked me out at first. I didn't expect the prints to go away. So it is in front of us. Set forward. Forward equals 0.5. Are we never calling calculate steering? Because we're not walking? Oh, yeah. And, oh, because, oh, shoot. This is my own dumb fault. We never... For our alternate probe, we never call calculate steering. So we never, for this fake probe, we never call calculate steering, so we never see anything. So regardless of all that steering, if we want to play with the alt probe, after we query the contacts, we should call vec3d, vec3d alt move equals, so I'm going to just put this just for debugging to help future Paul. No, this is not real code. Alt move equals new vec3d probe calculate steering. Yeah, I'm making dumb mistakes now. So move, so that's the direction we want to move. Alt move. Okay, so now, yay! Okay, so it's telling us there's something in front. And it should also be able to tell us what we want to do. Something in front. Desired movement. Default move. Okay, so desired movement is 0. So that's actually what we expect, but there's something in front. And if there's something in front, okay, something in front if it's a step. If closest is step, we can say step in front. Should say, whoopsie, no such property step. Closest step. Got too many things going on in my head right now. Okay, so there's a step in front of us. We know that, which means we could return. Well, so here's where we would want to check to see if our movement. So if we're moving mostly in the direction of the step, then allows, right? Then don't avoid, right? So we know we're moving in that direction. The step is in our way. That's okay. We won't steer around it. So how do we determine if it's in our path? We would take the move vector so we need to know relative step and so if that's true, relative step equals relative. So we know sort of, we already had to calculate it, so we might as well keep track of it. And so if the relative step position, the step relative to our center of gravity, is roughly in the direction of the move direction, but one of the, so the dot product is, so the dot of, so some vector dot some, or the v1, okay, so, sorry, v1 dot v2 equals the length of v1 times the length of v2 times the cosine of theta, where theta is the angle between the two vectors, right? When the length of these is 1, it cancels out and we just get the cosine of theta. And that's useful to us because when the cosine of theta is 1, that means, I don't know if you guys know your stuff, but you know, we've got an angle like this for a right triangle. You know, you got some angle theta. This is the cosine. So when something is directly in front of us, like it's this angle 0, cosine will be 1. When something is up this way, cosine will be 0. And so when these are both unit vectors, both length 1, it's very useful because we can say, we can use this to just determine what angle something is in front of us. Yeah, it does. In what sense, though? Plus, I do everything using MathD, which is my double math library, because I don't like to work in float. Too many precision errors. But using trig to calculate cosine theta, super expensive compared to a dot product, because dot product's just like 3 multiplies and then 2 adds, right? It's super cheap to get this for free. But the point is, when both of these, so when one of these vectors is normalized, you get this cool effect too, where you get the length projected onto there. So it would be the length times cosine theta, which is super useful for lots of things, and that's what we use for all of our steering. When neither of these is of length 1, then this is just a garbage value. It's not very useful except for to know when it's positive, you're kind of in the same direction. When it's negative, you're kind of in the same direction. So I need to normalize one of these is my point. And so we will vec3d, right, so relative rel equals relative, step relative, is that what I called it? So to your point, relative step. So relative step is not a normalized vector, but I can turn it into one by calling normalize on it. And, but you know what? Let's do move instead. Move dir. Because we could be sitting right on top of, actually I'm not sure it's going to matter. What I want to avoid is when they're of length 0. Normalize is going to return garbage. So if, all right, let's so what do I want to do? Let me just write it out. If move dot length squared equals 0, then we want to do special stuff. Else, we can do the thing. So if we're not even trying to move, there's really no point in doing anything else, and maybe we shouldn't have even been our default move. And maybe we shouldn't have even been worrying about it. Yeah, so if default move is just return false. We don't need to steer around something if we're not moving. Probably. Maybe. That actually could have been something that was getting us in trouble. So anyway, so then we don't need the else because we've already returned. So we'll normalize the move direction. F equals move dir dot step, relative step, is that what I call it? Relative step, yep. So if it's in front of us, if f is greater than 0, print line step up. Uh-oh. Okay, because relative is 0, because the contact is sitting right there. Because this is the relative, no, it should be relative to our body. What am I thinking? Oh, move dir 0. I already returned. Ha ha ha, we're not moving. So what if I do... Yeah, so we can't test this any further. Step up, we can just return false. We didn't change anything. We can still print line step up if we want. Okay, so now we should be able to see stuff happen. Oh, well, what we'll see is that she won't try to steer away anymore, I think is what we'll see. So let's try to arrive up the steps. Yeah, she's we got a couple step ups, I think, before she yep, she tried to step up. Let's move her back over to here. Okay, let's get her to try to step up here. So yeah, she's trying to step up. But some of the stuff is not... I need to get rid of the speed. So we're up here. Yes, she tries to go there, but there's some part of the steering that's still... the body level steering that's still trying to make her step away. So I need to sort that out, and to do that I need to turn off that speed, because that's going to just swamp us. Okay, so that's that. And then let's turn off the alt probe for a second. It's still there. Ooh. Oh, because the debugging for the alt probe is still there. Let's turn def boolean. Oh, not def boolean. I cannot type. Has alt probe equals false, and then we'll search for alt probe and wherever it is. So if has alt probe, do this. Okay, so we got another thing. Notice it probably has alt probe for now state. Okay, alt probe, alt probe, alt probe, alt probe, alt probe, alt probe, alt probe. If state dot has alt probe. So now we got a little debugging thing we can turn off and on, but right now we've just got the one, and we've got that way we won't see a lot of extra debugging output when we're seeing this step up. So if we don't see a step up, let's turning away from closest.cp, or is it contact point? Okay, so now we'll see stuff when we try to walk up to figure out why she's still turning away. And it could be that, no, it was just like even if she slowed down, she shouldn't still be trying to turn away. So let's try to arrive up here and see what happens. So she had step ups. She's turning away from something that was directly in front of her. Or not just there directly, I mean directly at the same level. So it is a horizontal contact at, so just below, let me mark this so we can see. I should say, let's add some asterisks here and put the same thing. So what's happening is that closest is not equal to closest step necessarily. I think the body offset, no, that should be the same. I don't know. That's why we're debugging. As you add logging, it's important to kind of speculate, hypothesize what you expect to happen. Arrive here. Okay, and that didn't work. Okay, so go back over there. And so we had all these. We started working. Arrive at there. She got some steps up immediately. Step up to 4.5. Say what? That was like right on top of us. Or inside of us. Oh, our probe was inside the... Our probe sits a little ahead of us, so it was inside the wall. That's fine. We knew we should step up there. That's fine. Literally, yeah, it was like right... A z of 0 means that the contact point was right inside the sphere, like we were getting when we were testing. But then it's turning away, because it gets a contact also at 0, meaning we're sitting right inside of it. It's 0 distance away from whatever this is, whether it's the probe or the rigid body, I can't tell. But it's essentially the same. Interesting. Well, what we can do is we'll have to look fast, but because we're capturing all of the, I can just say another one here. We don't care. No, we should already be debugging the contacts. Yeah, so that's fine. Like whatever contacts we got, we should be seeing them, and I think we were. But it's like they don't freeze in place. Ah, we could not clear. We just could not clear out the old ones. We'll get a lot of contacts. Yeah, there's no good solution for that. See, what I worry about is that as soon as she starts trying to step up there, she's going to turn away, and that's going to... There's definitely something weird going on. I'm not exactly sure the best way to debug it. I almost want to get her to pause and single step the physics engine. Let's see what the contacts are doing. She gets... Oh, no, we're not even getting debug contacts. Okay, so we shouldn't be getting any step ups. Turning away, turning away, turning away. She's turning away, turning away, turning away. She's trying to step up. But somehow she's still getting contacts to turn away. But why though? So here's where we said, you know, walk there, and initially she gets all the step ups she wants. And then she gets one that says she should turn away. But I don't know why. Like if we printed the contact normals here, where? Closest contact normal. This might clarify some things. Arrive. Okay, so we should get some good data there. That's the second arrive at. We don't care about that one. It's the first arrive at we care about. Where did that go? There it is. Okay. So we immediately got some step ups. That's what we expected. And then we were turning away from a contact that we are trying to move up, and the contact is pointing down. No, it's pointing in that direction. I wonder if it's because our move vector... So the move vector that we're comparing against includes the y value. And I think that's not right. Because when we dot those together, that's going to make things interesting. So what we want to do is we want to say like 3D move dir equals default move clone move dir.y equals 0. If move dir is still 0, so basically we're getting rid of the y deflection, then we move dir normalize local. Because what was happening is we were getting, our vectors weren't facing flat, they were facing up. And so when we had a contact position that was below that, it looked like it was facing in the wrong direction. That's because f could be negative because it's behind the vector kind of thing when it's pointing straight up or straight back. I think maybe this will make it better. I don't know if it'll fix all the things, but we'll see. She should just keep trying to walk in that direction. Nope. She did not. In fact, I would say it's almost worse. Okay. Arrive here. Yeah. She's got problems. Yeah, this is partly because her probe is incorrectly set up. Like I said, it needs to be tall to catch these cases. So jump, so we get a little bit of stuff there, and then arrive here, and then arrive back here. I want to see that first. We may have made the problem worse. Okay, so now we got lots of step ups, step, 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 and then we started turning away from something in about the same place, but just slightly below where our probe is. No, it's down in the... Wait, she's standing on 4.81. So that's, yeah, slightly below where our probe is. And so the default move is that. I need to not log default move is what I need. Oh, am I using contact normal? No. First of all, I want, oops. I want that so that I can see the flattened version for now. I'll forget that I did that later and be like wigged out by the y value being zeroed out. But I'm not sure that's going to help me. The default move was up. We can ignore that part. Roughly in Z, so this is basically directly facing into us, and so we would try to turn away. It's because the contact normal is horizontal, but why though? Why though? I wonder if it's because our probe moves. What if we don't adjust the probe? When I do calculations, when I do contact calculations, come on, Miro, why you gotta do this to me? So if you think of, there's a box here and a circle intersecting this, it's like, where does it contact? And so normally you would try to figure out, basically, if it's like this, you'd probably want the contact point to be here, right? But if it's like this, you'd want the contact point to be here. And if it's like this, you'd want the contact point to be here, right? And so it tries to figure out what's the quickest direction that I can push this sphere out of the square so that it will get out, and it uses that as a contact point. But that means when it is on these corners, it becomes a little bit ambiguous which way to go, because as it moves down, this contact point will move down, right? Because that's the center of the sphere. And so where we did at first have this up vector here, it doesn't take much for it to move and become a back vector. So I'm wondering if we just go ahead and try to get the player to step up. The thing is, the probe is going to make us steer away. Always chicksy these physics things. I mean, the regular video game thing, right, is as soon as they try to do that, they step up. So let's do like the lame video game. If they climb the steps, they like shoot up into the air kind of thing. Calculate steering. If we want to step up, let's set the steering to step up. Move dot y equals move default move dot y. So let's just go up as much as we want to go up. And so down here, we need to start paying attention. Okay, so probe movement input, that's fine. Our regular move, we only want to pay attention to the Y and these. And in fact, probably only if it's positive, in fact. This equals 0. And move dot y, or default move y is greater than 0. Then set it else if f is greater than 0. Return false. We'll just ignore steps for the moment. This is where I'll spend my life, by the way, in this pathfinding stuff, is these kind of contact debugging situations. Okay, so if we get up-down movement from here, we don't want to do the forces on that, but we will pass it through all these guys. And if the steering says, after contact avoidance, that we should still move up, then we shall. That's all the contact. So if, excuse me, here where we set the force equal to 0, we target velocity equals figure out the velocity change necessary. I don't know why we zero out that force. We're not setting it. Oh, here it is. Target velocity is less than actual velocity. Sure. But let us set it to probe, what do we call it? Probe movement input dot y. Probe movement input dot y. So that it'll get an upward force by quite a bit, in fact. So let's see if she'll walk up steps. God, I hope this works. Nope. Why for? How come? Okay. If force dot y is greater than 0, print line up, 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 force dot y. And let me remove this other debug. So we'll maybe see some of that. Arrive here. Up, up, up. Maybe it just wasn't up enough. Okay, come back over here. Mythruna girl, come back. Return! So what do I hit? When I hit jump, what do I give her? Because I would have liked her to have jumped, basically. Let me see what I do for jump. I just set her linear velocity to 4, so that's not really helpful. Let's set this to be times 10. Let's just make sure. Right, well, let's just verify that her up, up, and away. Up, up, up. Where did it go? Oh, turning away, that's not it. Up, up, up. Force of 143. Force equals mass times acceleration. So it's actually not a big velocity. Not a big velocity change anyway. So let's try this to see if it does more. Arrive. Boink. She moved up a little bit, I think. Let's just make it crazy. See what happens. If she goes shooting up into the sky, we'll know we're on the right track at least. Spook. Yeah. All right. Don't know. There she goes. We are on the right track. Okay, so 1,000 is too much. Arrive. Boink. Okay. Okay, she can jump up. Task failed successfully. Exactly. So she should be able to just fall back down. Yep. Okay. Oh man, that was awesome. Okay, so something like 50. This isn't right, but because I'd like her to slowly kind of step up, almost like a climb. And again, if she had the animation, she would just do it automatically because she'd hook on the edge. But oh man. Okay, so let's see if she can make it all the way up here. Boink. Yeah, because the arrive said go all the way up there. So what was the up, up, and away on this one? I think that I need to not multiply it by the desired y. Let's let's change this to be probe movement input. Oops. Oh man, that was awesome. So I just want to see what it is for the short version, because I think it should probably be a constant. And we can just arrive up here. Oops, except for we've got to not be blink. It's funny looking, but it's funny looking in a cool way. Where's the up, up, up? Oh, I think it's down here. She wouldn't have done it too many frames. Okay, so no, that's not right. This is it. So 0.32. So let's just set it to be a constant. Let's do this. So if probe movement input dot y is greater than 0, set force y equal to let's just try 1. The values were really small before. Okay, let's have her walk back down. Come back down here. Come on, Mythruna girl. Come on, Fade. Come back down. Okay. Okay, you're not arriving. There you go. Alright, so let's try going back up. Boink, boink. Boy. Okay, so the 1 is not enough. Alright, so let's set it to 10. And you want to arrive up here. Boink. Oh, she almost made it up. Let's come back over here. Arrive here. Come on. Oh, she almost did. Okay, so right back over here. Come on. Okay, warp here. So you can arrive to where you're supposed to go. Okay, so let's just try arriving to here. What happens? Okay, so it is just not quite enough. She gets distracted by her own contacts before she gets there. Okay, warp here. There you go. So let's try 50, which I think is maybe going to be a little aggressive. Boink. Yeah, 50 is too aggressive. Wow, it goes from not being really. So we had it at 10 before. Let's make it 20. So she was like on the cusp of being in the right ballpark for that, I guess. Arrive here. Boink. Okay, that's not too bad. Arrive here. She doesn't fall again. Oh, because I used to zero out the force, else force y equals 0. Yeah, okay. So you come back down here. I like that she can walk down the stairs, though. That's nice. Yeah, so she can just fall right down. That's cool. So arrive. Can you get up to 1 step? Whoa, okay, so yeah, okay. That's too aggressive. So let's bump it back down. Arrive. Boink. Hey, check it out. Okay, so you go down here. Let's see if you can walk all the way up the steps. Alright, arrive up here. Oh, she's going to have to find her way around. Well, warp here. Yep, she did it. Which means if we have her arrive over here, she just jumps right off. That's pretty cool. Okay, so path to here. Oops, no, path to here. Stop going inside the thing. There we go. Now, step, step, step. Find your way up the stairs. There we go. Okay, let's see what she does. And this will be where we end it. Man, this took so long. Walk the path. Walk the path, baby. Oh, no. Oh, no. But why, though? Why doesn't she want to go up? Okay, she does. She just got caught. Okay. So she steered away from where it would have led her up, and so probably she gets caught up on this, I'm imagining. Which actually could be a pathfinding problem now that I think about it. Like, the pathfinding queries should have detected that and maybe made her walk a little more over this way. But let's make her arrive down here. She should plop right off. Okay. So we want to clear the path. Path to back up here. Yeah, so there's some cleanup that's still got to happen because it left these doo-doos behind. Step, 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 step. She might make it up this way. So let's see. Walk the path. Come on. Come on, girl. Do it. You can do it. Oh, there she goes. Look at that. All right. Oh, my God. Come on. You can do it. Yay! Yay! All right. So, in principle, this is working. Oh, man. Math, though, eh? My brain is tapioca from this week already. So again, like I said, my whole life is going to be figuring out these little physics conundrums. But that means she should be able to walk over to, like, even just arrive over here. She should be able to do that. Boink. Boink. Yep, look at that. Whee! Nice. So can she path over to here? I always do this, like, I have, like, these great moments where I've had success, and then I destroy it right before the end of the video by doing something that's too hard. I kind of hope she'd go this way, but that's okay. Walk path. So she should fall down, that's fine. And she almost fell off the corner there. Now, can she come back? Path to here. Step, step, step. Okay, can she walk up that? She's like really kind of in a precarious situation here, so I'm really making her work for it. Yep, she can. Oh, the other issue is, and I knew this from before, so somebody pointed out, like, when she's turning corners and stuff, she probably shouldn't be leading so far ahead. And it occurred to me that some of the problems she's having with navigating her paths are because that her target is so far ahead. It's a full meter ahead on her path. You know, she's walking this, like, if I warp her back here, right, she's trying to aim towards this. And if she was really here, this is quite a turn to make. And so I'm almost thinking I need one really near to her and one over here, and then make decisions based on that. Like, if this direction is a lot different than this direction, then have her slow down. And because she would be slowing down, this should move closer, and she should be able to navigate corners better. And that actually might also fix the step problem. That's not something we're going to do tonight. I need to stop on success. I need to go into tomorrow feeling good about things. I'm glad you guys hung around. All 6 of you, according to that. That's awesome. I'm glad that this is content you guys find enjoyable, because I certainly find it fun to mess with. And I'm sorry a lot of it was just looking at a blue screen of code, but thanks so much for that. If you have any final questions as I start to wrap things up, please let me know. Otherwise, I'm going to start doing the thank you music. So thanks for watching. Please like, comment, subscribe, and I hope you all have a great week and productive week. And I hope things are looking better for you guys as the weeks go on. I certainly hope to have a lighter week this week than I did last week. Hopefully lots of new Mythruna stuff to do next weekend. I'm not sure exactly what the live stream will be. Probably continuation of this, because we'll have to start dealing with different mob types and stuff. Thanks so much. I'll see you guys next time.